Ever wonder how a clock keeps perfect time? Clocks are devices designed to measure and display the passage of time, and while they come in many forms, from ancient sundials to atomic clocks, their basic function remains the same, dividing time into consistent, repeatable units. The most traditional type is the mechanical clock, which operates using a combination of gears, springs, and oscillating components. At the heart of a mechanical clock is the mainspring, a tightly wound coil of metal that stores potential energy. When released, it unwinds slowly, transferring energy to a series of gears and levers that control the movement of the clock hands. The key regulating component is the escapement mechanism, which divides the release of energy into precise intervals. Attached to the escapement is the pendulum or balance wheel, which swings or oscillates back and forth at a steady rate. Each swing allows a tooth of the escapement to escape, moving the gears forward by a small, consistent rate. This is how seconds, minutes, and hours are measured. Modern quartz clocks work differently. Instead of mechanical parts, they use the consistent vibration of a quartz crystal to keep time. When an electric current passes through the crystal, it vibrates at a precise frequency, usually 32,768 times per second. This frequency is counted by a circuit and then translated into regular electrical pulses, which drive a small motor that moves the clock hands or updates a digital display. Atomic clocks, the most accurate of all, measure the vibrations of atoms, often cesium or rubidium, whose energy levels change at ultra-precise frequencies. These clocks are so accurate they would only lose a second every few million years. Regardless of type, all clocks function by creating regular, predictable cycles, whether it's the swing of a pendulum, the vibration of a crystal, or the resonance of an atom, and using those cycles to count and display time in a way that we can understand and use in daily life. In short, we can say, let's break it down. Step 1. The power source, usually a battery, gets things ticking. Step 2. Gears and springs work together to move the hands. Step 3. The escapement controls the release of energy, keeping time steady. And there you have it, a perfectly synchronized dance of mechanics. The next time you check the time, you'll know the magic behind it.